Good morning, students. The last class we have seen about types of loads. Okay. Next class we are going to discuss about load equalization. Then keep reading load equalization. So in generally, how can you equal the load? How can equal the load? The load is considered mainly three ways. One is for this and first one, low loads, high loads, and medium loads. Medium loads is termed as a constant loads, low and high. So these two we can call as an fluctuation. These two we can call as an fluctuations. Removing these fluctuation, we can get the load equalization. If the motor is running constant, then automatically you can call as a load equalization. Okay, simply that to define as that load equalization, the smoothing out of fluctuations in the load is called load equalization. Okay, the definition is that the smoothing out of fluctuations in the load is called load equalization. Okay, this can be done by using flywheel. It gives constant output irrespective of the input. The main function of flywheels is that it will give constant output irrespective of the input. Okay, while in peak loads it supplies stored energy and change duration of loads. While in peak loads, in case motor is getting peak load, it supplies stored energy and changes during off loads. Okay, next one, load torque required and actual motor torque developed are shown in see here are shown in thick and chain dotted lines respectively. Thick and chain. Now see here, load torque and actual motor torque developed. That two torques, load torque is represented as a thick and chain dotted represented as a lines is respectively. See that picture is versus time versus torque and time versus speed. Okay, one case is that speed with flywheel and second case is that speed without flywheel. Okay, and similarly for the second application of is that time versus torque. Here also motor torque and load torque the representation. Now let us see the practical expression about the load equalization. Okay, so totally derivation, let us assume let T1 is that load torque and TL is the load torque, Tm is the motor developed torque in kg meters, Tf is the torque supplied by the flywheel. F indicates to flywheel, and J is the moment of inertia, and T is time in seconds, and omega is speed of motor at any instant in radians per second. Speed of a motor at any instant in radians per second. These are all that assumptions. And next omega naught is that no omega is speed and omega naught is no load speed. S is the slip of the motor of full load, and G is the gravitational acceleration. That is equal to omega naught minus omega. Okay, these are the all considerations about load equalization. Now we have to equate the derivation. First one, two cases, though totally two cases exist for this and load equalization. One is increasing case, one is a decreasing case. Now we will see first one, load increasing case. The motor developed by the torque is equal to load torque minus freewheeling load torque. Okay, now see here, when the speed of flywheel decreases, it gives it energy where E equal to 1 by 2 J by G. J is moment of inertia and G is gravitational acceleration of omega naught square minus omega square. Okay, let omega naught minus omega is equal to S, representation omega naught minus omega S. So that will be splitted, the value E is equal to J by G S omega, J by G S omega, where omega is equal to average speed omega naught plus omega by 2 average speed. Okay, power gives out by the flywheel, dE by dt is equal to jg omega ds by dt, dE by dt j by s omega ds by dt. Just simply have to take the derivative of this above expression, that is an dE by with respect to time t, dE by dt is equal to j by s omega ds by dt. Therefore total torque exerted, that is equal to power by omega. Just you have to write that power equation by omega. So I have to do that cancellation term, the remaining expression, that is an j by g into ds by dt. So therefore Tm is equal to TL minus j by s into ds by dt. That is for this freewheeling supplied by the load torque. Okay, next one, in case of an induction motor, torque is exerted by the motor. The position of a speed torque characteristic is proportional to slip, that is S is equal to K Tm, that is S is equal to K Tm. Next we have to again this value substitute in our original equation. Tm is equal to T1 minus j by s ds by dt, that is equal to Tm is equal to T1 minus j by g k into dTm by dt, where s is replaced, that term k is constant and motor torque. Okay, now simplify this expression, jk by g dTm by dt, that is equal to TL minus Tm. Now integrating on both sides. Now here is the equal expression, integral of an dTm by T1 and TLTm, that is equal to g by jk integral of a dt. So integrate this expression, you will get the result is that minus log e TL minus Tm, that is equal to g by jk t plus c, where c is constant, that is simply can written as that minus log T1 minus T naught. Therefore g by jk t is equal to log e of T1 minus T naught by T1 minus Tm, that is equal to log is move this side, at that time e power gt by jk, that is equal to T1 minus T naught by T1 minus TL minus Tm, that is equal to TL minus Tm, that cross multiplied we will get the result is the TL minus T naught e power minus g by jk into t. Therefore Tm is equal to T1 minus of T1 minus T naught e power minus g by jk into t. Say this equation number 1. Okay, that is about for this load increasing. And next case is go for load decreasing. At the flywheeling speed yes, flywheeling speed s, the slip value is ds by dt is negative. That's all. The remaining pattern is same thing. That is an Tm is equal to T naught plus Tf, that is the original equation. Then Tm is equal to T naught minus j by g ds into ds by dt. Tm is equal to T naught minus j by gk into dTm by dt, j by s k into dTm by dt, that is equal to T naught Tm. That simply finally again integrating on both sides we will get that expression, that is minus integral of dTm by Tm minus dt naught, that is equal to g by jk integral of n dt. Now similarly equation 1 we will get this result. Substitute in equation 1, the final result Tm is equal to T naught plus Tm minus T naught of g e power minus g by jk into t, where Tm dash, the torque of the motor time constant is load is removed. Okay, this is about load equalization. Okay, without fluctuation. Simply that motor is called as a load equalizing. After that equalized load, the derivative part will consider as a load increasing case as well as an load decreasing case. If the load is an increasing, then how the going to be the expression here? Considering some parameters, based upon parameters we need to consider that the increasing and decreasing values. Okay, next in similarly for that case is that load decreasing order. So I go above that expressions is similar to the supply considered is a the slip value is minus finally submit the total results, you'll get that load equalization. Okay, this is about load equalization. Okay, thank you.